Okay, good morning, everyone, and thanks for joining us in time. We are waiting just a few minutes more to let everyone connect.
No.
Okay, then I think we can start. So, good morning again, and welcome to our webinar dedicated to GuestXR OpenCall. I am Simona Neri. I'm the project coordinator, and I'm here today together with Mel Slater, the technical coordinator. So here you can see we have the agenda. So the morning is divided mainly in two different sections. The first one in which we will have the explanation of the technical developments we had in our project. So you will get all the technical details of the technologies of GuestXR. And then we will have a second part that will be mainly dedicated to the OpenCall guidelines and application process. We are going to take also questions, and so feel free to write them in the chat. But we will also have two dedicated slots at the end of the first part and at the end of the second one, in which you can also just raise your hand, and we will be happy to take your question, open your microphone. So we will start our session with a brief overview of the project that will be given by Mel Slater. Mel Slater is the technical coordinator, as I said, and he is also distinguished investigator at the University of Barcelona and co-director of the Event Lab, Experimental Virtual Environments for Neuroscience and Technology. So thanks a lot, Mel, for being here, and I give you the floor.
Thanks very much. Thanks, everyone, for attending. I'm going to give a very brief overview of the GuestXR ideas behind the project. And first of all, the main points I'm going to make are that people behave in shared virtual meetings much as they do in physical reality. And I'm going to use proxemics as an example. Then make the point, which is kind of obvious. I think that virtual meetings can go wrong, just like real meetings. In the worst case, with abuse and harassment. And the fundamental idea of GuestXR is that meetings can be improved through artificial intelligence interventions. All the details of this, or some of the details, will be explained by the subsequent speakers. So I'll start with this video.
There's a theory that you have 4 zones of personal space. The public space, the social space, personal space, the intimate space. So, this is for the public. This is for new friends and acquaintances. Good friends only. And this is for family, boyfriend, girlfriend, and pets.
So proxemics actually works exactly the same in VR. So proxemics is this sense of different level types of space that you should maintain with other people depending on your relationship with them. So in 2003, Jeremy Bailenson published a paper that showed that people maintained greater distance from virtual humans when approaching them from a front compared with the back. And the distance was greater when virtual humans were engaged in mutual gaze. We did a study here in 2010 where groups of characters approached you, and not only did we find that the same kind of distance relationships held, but we also found the same results that the person who first wrote about proxemics, Hall. He found that skin conductance increases as people get closer to you, and we found exactly the same thing. So proxemics in virtual reality is so consistent that, it's so consistent, my video is not working, doesn't really matter. The proxemics is so consistent that a reinforcement learning agent was able to learn to get people to a target location in virtual reality in 7 minutes, even though they didn't know that this is where they were meant to go. Essentially what happened is that the reinforcement learning agent learned human proxemics. It learned that if it went close to a person, they would back away. If it was too far from the person and that didn't work, it would wave for them to come closer. And when they come closer, it would then move towards them. And again, the person would back away. So this idea of using, in this case, reinforcement learning to achieve certain human behaviors is closer to the idea of GuestXR. Why am I talking about proxemics? Because proxemics behavior in VR is similar to proxemics behavior in reality. And our thesis in this project is that this applies to everything, not just to proxemics, that social behavior in virtual reality is at least equivalent to social behavior in reality. Why do people act as if they're with others? Well, a very famous social scientist, Irving Goffman, made it clear that co-presence involves two moments. One, when individuals sense they're able to perceive others, which obviously happens in virtual reality. And second, when others are able to perceive them. And social presence, this sense of being with others, goes right back to the early days of virtual reality, like with this paper by Heater into 1992 called Being There, the Subjective Experience of Presence, where she talks about co-presence, this sensation of being there with others, even if the others are not real people, but virtual people. So sharing the same space with people is like really different from what we're doing right now, which is just seeing little screen video images of each other. It's really different. So when you share the same space in virtual reality, you have gestures, gaze directions, proximity. It doesn't matter what these people are saying, but you can see that they're in a meeting together. They have the illusion of being with the other people. They have proxemics relations with each other, and so on. And this, of course, maybe this is why we started this work, that during the confinement in my group, in my lab, we were having our meetings using this shared virtual reality system. So hitherto, shared virtual reality has been limited. I mean, it's very expensive to have lots of labs with a virtual reality system, but now the hardware costs are really minimal. I mean, it's cheaper now to have a good head-mounted display than it is to have an iPhone. Global companies are moving into the space of these massive virtual worlds like Metaverse, Horizon, VR Chat, AltSpace VR, many others. But of course, the Metaverse has problems. This idea of shared virtual reality or even augmented reality when you're with other people, it has problems, and it's really easy just to go onto Google and type in metaverse or virtual reality or collaborative virtual environments harassment, and you'll find all these kind of articles like the ones I found here. So GuestXR, this machine learning agent for social harmony, its fundamental assumption is that any meeting always has a purpose, even if that purpose is just people to have fun or enjoy themselves. And that this purpose can be operationalized, like making people to physically mix together, maximize positive emotions, maximize turn taking, whatever it is. So the purpose can be turned into operational statements about and facts about how you want the meeting to be. And once it's been operationalized, the machine learning agent can learn how to maximize the chance of these operational requirements. So for example, a meeting is in a mess, but a guest, like in reality, if a meeting's in a mess, a guest turns up and sorts everything out. That's basically the idea GuestXR, except the guest is an AI. And it doesn't mean the AI is embodied as a virtual person. It could be anything, changes in lighting, changes in music, combinations of different actions. So it attempts to realize goals. Since the shared virtual environment is virtual, it may be possible to have interventions to help participants realize their goals. So you have meetings that are positive for everyone, engaging, effective, people don't get stuck, not dominated by a clique, and so on. So, you know, like imagine there's an office party and it breaks up into cliques. The agent will try to initiate actions that brings the two cliques together, like having a queue of virtual people between the two cliques. The virtual person at each end starts engaging in conversation with people in the two cliques, and gradually the queue shrinks and shrinks, bringing the two cliques together. This is just like an example of the kind of thing that a reinforcement learning agent may come up with. And the reward in this case will be based on the physical distance between the individuals. So the GuestXR structure is a number of work packages. The top one here is machine learning, then extended reality, multisensory, including haptics, various applications, and social modeling and neuroscience, which feeds into the machine learning, which feeds into the XR, and so on. And behind everything is applied ethics. And these are the partners involved. And finally, the GuestXR has a number of use cases. These use cases are to have a persistent virtual meeting place, inclusivity for people with hearing loss, conflict resolution, a climate change use case, and of course now the open call. And the idea of the open call is that it will bring new use cases into GuestXR. And as I said, ethics is behind everything. So this provides an opportunity for others outside the consortium to suggest a use case. This use case will be carried out in conjunction with members of the consortium. There's no actual funding available, but there is access to consortium resources. So now I hand you back to Simona, who will then lead the rest of the meeting. Thank you.
Thanks a lot, Mel, for the clear presentation. So as it is written in the chat, remember that we are going to take the question at the end of this section of technical explanation of the technology of GuestXR, and you can write them down in the chat, or then we will open the microphone at the end of the section. So, I would like to welcome Bernhard to open the camera and to share the presentation. Okay, so now we move to the presentation of XR environment with full body avatars and AI integration. The presentation will be given by Bernhard Spandlang. He's a co-founder and CTO of Virtual Body Works, a partner of GuestXR, that is a spin-out company of the University of Barcelona, that exploits the effects of virtual reality embodiment and to implicitly change people's behavior for good. He's a computer scientist with over 25 years of experience in developing computer graphics and virtual reality systems. So thanks a lot, Bernhard, and please.
Can you hear me? So,
yes, we can.
Great. So yeah, welcome to my presentation. Good morning, everyone. I'm going to give you first an overview. So I'm going to talk a little bit about embodiment and then basically give you a little bit of technical background on the system that we're building, and then going to give you a lot of examples of videos showing how the system works. And finally, we'll draw some conclusions and tell you about ongoing work. So most of our work is based on virtual reality embodiment, which is that we are exploiting full body avatars that we are embodied in. So that means that we have agency over that virtual body, meaning that when we move our real body, that virtual body would also move. And this exploits brain plasticity, so that we as humans basically adapt very quickly to a virtual body. And this can be exploited in various ways for implicit learning or for changing bias. So here you see an example where there's a person body tracked and you see the avatar moving at the same time. And this is changing a person's behavior, depending on which avatar is shown. In GuestXR, we are stepping a bit further, as Mel explained already. We are dealing with a shared virtual environment where there are people from remote places meeting with full body avatars. So here you see a diagram on the left. This illustrates people meeting in this shared space. And there is, in addition to just people meeting, an AI system observing these people and watching their states. And this AI system has a goal to achieve, which it can achieve by applying actions to this environment. So possible actions would be to change the appearance of an avatar of a person, or to add and move around a humanoid agent or multiple humanoid agents, or it could have different types of look-at behaviors or change aspects of the environment, like it could play background sounds or change the lighting or whatever it thinks is necessary to achieve its goal. In addition, now with large language models, we also have the possibility to listen to participants, turn that audio into text, and then react to it through a large language model and have agents talk back in that shared environment. So here's a general overview of the system. So a person in the middle, he would have wearing a head-mounted display, is connected through Wi-Fi to a cloud system. In our cloud system, we store experiences which contain avatars, environments, and some metadata that describes what happens in that experience. And also we can record people's movement and audio and even face movements and eye movements. On the right side, you see an illustration of the AI server, which would connect to that shared virtual environment and can do these changes that I was mentioning before, like changing avatars or changing the environment, and carrying out speech to text and text to speech to have conversations with virtual agents. This system we made available on the Meta Quest devices, and it's also available on the Meta Store through this AppLab infrastructure. So upon invitation, we can share this system with users, and there is the possibility for personalized avatars, and it offers a choice of experiences. And these experiences one of these experiences is something that will be developed in that OpenCall. And there are the other experiences that Mel mentioned regarding use cases in the project. So through this AppLab system, it's basically possible to install the application without any additional hardware or computers. And you can just run it in the head-mounted display. It's currently restricted to Meta Quest devices, but that could be changed. So here's an example where there's just two people meeting, me and one of our developers, we're just exchanging speech through voice and body movement and using facial expressions and eye movement. So here an example video. Okay. So participants can see themselves in a mirror, share facial expressions. So it's a natural interaction possible in the virtual environment.
Oh, yes. Eyebrows.
So this is using the MetaQuest Pro, which allows us to track facial expressions and share them in the experience.
Closing the eyes, opening again, thinking. Right.
Okay. Right. Another example here, which is a summary of a lot of possibilities of the system, which I'm just going to show. It's basically showing possibility of meeting between people, having full body avatars, natural interactions, insertion of an AI client, being able to change avatars and changing the appearance of the environment. And in addition, also the possibility to change the hearing of people through the head-related transfer functions.
Yeah.
Okay, so I'm Bernard.
I am Roger. Hello.
David.
So this is an example team meeting of Virtual Bodyworks,
Elena.
where there is possibility for seated and standing avatars. They can look at each other. there's spatial audio, and the possibility to change light.
When Elena speaks now, it's definitely here.
Yeah, same with you.
Oh wow.
No mirror here.
Who's the real one?
So here's showing the possibility of changing people's appearance while they are embodied in their original avatar. So everyone's not the same avatar.
It's Matrix, no?
In the code, which is the questionnaires, which could act as that as well.
Here, possibility to grasp objects and again a virtual mirror.
So yeah, we would need the text script to show in front of people if we want that.
Yeah, but if the script is too long, maybe you need more like a prompter, because the questionnaire will just show all the text at once.
You can also scale them. If you take them with both hands, you can scale them up.
Really? Wow.
Really?
Wow.
Oh, men är happy
Wow.
What a cup of coffee.
And this is a useful functionality. We noticed that is very good to make avatars disappear when the actual user is not there anymore, to make their avatars not appear in some funny position. Here's another example of a self-conversation where it shows the possibility to swap body with a virtual agent. So here again, virtual mirror with facial expressions. And then there are two agents in that room. There's one Sigmund that looks like Sigmund Freud and one that looks like Albert Einstein.
Hi, Sigmund. Hi, Sigmund. I keep on having nightmares. What should I do?
So here there's the possibility to swap with the agent and then be the agent, embodied as the agent. In this case, Sigmund Freud, and then there's Albert Einstein. And in this example, there's the possibility to have the self-conversation from two different perspectives, and at the same time, there's
What are your nightmares about?
The AI system listening, and when asked, it can be giving advice.
It's I'm being followed by strangers in the darkness, and it's really scary. What could I do?
So here the request to get advice from the AI is triggered by this button press of the help button. And
nightmares can be distressing, but here are a few suggestions to help. 1. Establish a consistent sleep routine. 2. Create a relaxing sleep environment. 3. Avoid stimulating activities before bedtime. 4. Practice stress reducing.
So this is just exploiting the latest large language model systems and integrating them with our system. Here's another example where the large language model has generated a conversation between three avatars. There's like another, again, Sigmund Freud, Albert Einstein, and Mel Slater's avatar. And they are asked to make a conversation about the meaning of life. And this is automatically generated by ChatGPT, then turned into voice by a text-to-speech system. And this can be generated very quickly and automatically.
And as a physicist, I've always been fascinated by the fundamental principles governing the universe. I believe that our pursuit of understanding these principles gives meaning to life. Our drive for knowledge enables us to unravel the mysteries of the cosmos and our place within it.
Albert, your perspective is intriguing. As a virtual reality researcher, I see meaning.
And here the voices are cloned from the real people. So from Mel's voice, it's quite noticeable. And those of
reality and sense of purpose.
Einstein and Freud are cloned from a YouTube video.
Present interesting viewpoints. As a psychoanalyst, I posit that the meaning of life lies in reconciling our unconscious desires with the demands of reality.
Right. The system, as in the XR of the GuestXR project, also supports augmented reality. So here I show an example of a recorded conversation in augmented reality. So this is exploiting the color pass-through of the Quest Pro, and it's possible to have avatars in a real room.
Do feel free to join in.
Absolutely.
I know that part of your remit is to visit as many of the company's teams as possible.
So these are full body recordings, and
very
also the audio
exciting
recordings
early
are from
stage
actors
of a new project.
and
We
replayed
made a
on these full
pitch
body
to the
avatars.
client, which we're all proud.
Right. So conclusions about this short presentation is we have this system that enables to have shared experiences, allowing natural interactions between participants through voice and body movements, face and eye movements. And there's this integration with this Python client that can connect to this shared environment and try to achieve a goal. So in our example, that could be, as Mel mentioned, like improve collaboration, increase empathy between people, or make a more interesting conversation between people. And it's also exploiting the possibility of implicit learning through embodiment in full body avatars and being able to change people's appearance. We have some ongoing work that Ren was going to talk about in the next or the upcoming talks. And also Anatol, we are integrating it currently with an EEG system to synchronize events in the environment to measure brain waves at the same time as the shared experience. And with Anatol, we're working on connecting this with their breathing belt, which he's going to talk more about. And in collaboration with Warsaw University, we're currently also developing a Tragedy of the Commons game that exploits all the capabilities of the system. Right. That concludes my talk.
Thanks a lot, Bernard.
Thank you.
So you got nice insights from Albert Einstein on how to improve your sleep. And also here you are getting some curiosity and a few questions. So in the meanwhile, if you want to read them, then we will reply them at the end of these presentations. So now we move on with the next presentation that will deal with the integration of different AI algorithms like reinforcement learning and large language models. And I would like to welcome Asaf Kraftori and Alon Shoa to join me opening their camera and sharing their presentations. So just a brief introduction. So they are both researcher. Asaf Kraftori is a reinforcement learning researcher at the Advanced Reality Lab, and Alon Shoa is a research engineering virtual reality and artificial intelligence and speech technologies. He has over 8 years of industry experience in audio processing, machine learning, voice applications such as ASR, speaker separation, voice biometrics, and NLP. So, guys, I give you the floor for your presentation.
Hello, everybody. I am Asaf and Alon, and we are representative from the Advanced Reality Lab in Reichman University in Herzliya, headed by Professor Doron Friedman. The research in the lab focus around the human-computer interaction, where we combine extended reality and artificial intelligence technologies. As part of our responsibility in the GUEST project, we are tasked with developing AI approaches to further the objective of the GUEST project. In this presentation, we will showcase our work in two distinct domains. First, we delve into the effort in reinforcement learning, and followed by our exploration of large language model in virtual reality. Alon? So today's agenda comprises several key points. We will begin by discussing social dilemmas the framework on which we focus to influence social behavior positively. Afterward, we will provide a brief background on reinforcement learning and explain how we have applied this approach to promote pro-social outcomes. Afterward, Alon will showcase his work with large language models in the context of virtual reality. So social dilemmas. There arises when individual rationality conflicts with the collective irrationality, leading to a situation where what benefits an individual may not be the best for the whole group. There are two main types of social dilemmas: resources dilemmas and public goods. In our approach, we treat human interaction as a social dilemma, where the tension is between the individual behavior and the overall group welfare. Our goal is to create an AI agent that can reconcile this tension, promoting a greater equality, peaceful coexistence, or increased productivity. To achieve this, we utilize reinforcement learning as a core technique in the design of the decision-making process of the AI agent. Here is a brief overview of the RL, how reinforcement learning works. In RL, our agent primary objective is to learn a policy that allows it to take action in the environment to maximize the rewards it receives. This achieves through a process of trial and error. The RL agent interacts with the environment by observing its current state and taking action accordingly. After each action, the environment provides the agent with reward based on the action's outcome. As the agent continues to interact with the environment over time, it learns from the reward it receives and adjusts its action to maximize the cumulative reward it expects to obtain in the future. In the context of the GUEST project, our approach involved training an RL agent to influence the emergent social behavior within a multi-user environment, such as conversation in virtual reality setting. Since reinforcement learning learns through trial and error, it requires a numerous iteration to effectively train the agent. To facilitate this learning process, we create simulations that accurately simulate social scenarios. The first step in our work is to design the simulation and ensuring that they are realistically mimic of social interaction. Once the simulation is in place, we incorporate the RL agent into them. This requires defining the agent observation, action, and most importantly, the reward signal that it should maximize. By structuring the reward appropriately, we aim to encourage the RL agent to promote more pro-social outcomes within the simulation social scenarios. In the next phase, we will transfer this training RL models into VR environment, where real humans are involved to test the RL agent performance and effectiveness in influencing social behavior while continue the agent policy. So the first simulation is the tragedy of the common. In this simulation, RL agent, represented by the red dots in the video you are seeing, trying to collect apples, represented by the green square, in a 2D environment. They can move, gather apples, and temporarily disable others or tag them with a yellow beam. In this setting, we are training them to obtain as much apples as they can. Despite the simplicity of this simulation, we observe a complex emergent behavior during the training process. As you can see in this video, they are collected all the apples and left to starve, basically. We measure matrices like efficiency, how many apples collected, aggressiveness, how many agents tagged, and equality, which is the difference between the individual's efficiency. We use those matrices to evaluate the social behavior during the training process. Pay attention. we treat the training process of the RED agent as a standalone process. Our goal is to learn at the same time a reward signal for this agent that encourage them to high efficiency while reducing the aggressiveness and promoting a fairness in the resources distribution. Instead of directly teaching the RL agent how to influence a social behavior, in this case, we are focusing on learning how to produce a reward that guide them toward a desired outcome. This method allows us to handle situations where we might don't know how to generate rewards directly, but we know the end goal we want to achieve, which again is more equally and less aggressive behavior. In the future, we plan to use this reward production method in various scenarios, enabling reinforcement agents to achieve specific objectives without explicitly guidance on how to get there. The next simulation developed by the University of Warsaw, again, they are part of the GUEST project, is the human conversation. In this simulation, the environment simulates a conversation among three individuals, computer agents, represented by the red heads, each having a different tendencies to talk, mirroring real human conversation dynamics. In each time step, all three agents have the opportunity to speak, while the RL model, represented by the greenish color, can influence each agent propensity to talk in the very close time. The primary goal of the RL agent is to enhance the equality of the conversation, ensuring a more balanced distribution of the airtime among the three agents. In the future work, this simulated agent will be replaced by real human in a virtual reality environment, and the RL model objective will remain unchanged, which is to promote equal participant and balancing in the VR conversation. And now we'll go to Alon. Alon, you are muted.
Hi. So my name is Alon, and I'm going to give, so my talk, I will do a short, a brief overview of large language models and how we leverage the personalities how we leverage large language models to create personalities, and then I'm going to show a showcase featuring a conversation that was live broadcast with Gurit Birenbaum and Sigmund Freud as and in a AR environment. So language models are models that are trying to capture to approximate language or language generation. So large language models are the same, are just language models but have a very large number of parameters, and the parameters are just the way that the model can learn. It's like it can be thought of as knobs that the model changes during training. And okay, so large language models have are basically usually GPT based, which are generate pre-trained models, and And those models are the foundations for applications like ChatGPT and GPT-4 with plugins or GPT search and so on. So in our lab and in my work, we created a persona, like reconstructed personas and created personas based on large language models, and we can define and we can configure the behavior based on big 5 traits, which is personality trait measurement used in psychology. And we also create a reconstruction of personas like Sigmund Freud, or which you will see in a minute, or Albert Einstein, and those can be used in live events with in live scenarios with real humans talking to them. So I will start to show the showcase. The showcase is a date with Freud. We will see Professor Gurit Birenbaum talking to Sigmund Freud in an AR that was live on stage with Reichman University. So I'm going to you can hear me. You can hear the screen. And just to give credit, so I would like to give credit to Gurit Birenbaum.
Hi, are you the famous Dr. Sigmund Freud?
Hello there. Yes, I am playing the role of Sigmund Freud, the famous psychoanalyst. How are you doing tonight?
Great, thank you. What inspired you to be a psychologist?
Well, I have always been fascinated by human behavior and the workings of the mind. I believe that understanding the human mind and its complexities can help us lead better lives and solve many societal problems. That's why I decided to delve deeper into the field of psychology and make it my life's work.
Can you tell us about your major findings?
Well, my major findings mostly revolved around the idea that people are in.
Okay, so I would stop here. This is just to show like the show that was produced, and I would like to give credit to Gurit Birenbaum, which was on stage talking to Sigmund Freud, and Yair Moss, who was the director of it, and Bar Zamur, which was which created the avatar, and Doron Friedman, who's the lab director. Thank you. Hope you enjoyed.
Thanks a lot. Now we move to the next presentation. So we have now Ren Chu. Okay. Okay. Thanks a lot. So he is a senior scientist at GTech, medical engineer in Austria, and his main research interests include biomedical signal processes, brain-computer interface, and its application in stroke rehabilitation and consciousness assessment. And he will give us a presentation about brain imaging technique. Thanks a lot, Ren.
Okay, hello everyone. It's my pleasure to give a presentation here. And today I will introduce brain imaging techniques. that can be used for GuestXR OpenCall. As you probably know, there are many types of ways to measuring the brain activities. As you can also see here, they are featured with different time resolution, spatial resolution, and also the hardware complexity and price. So for example, the FMR has excellent spatial resolution, but the time resolution is kind of limited. On the other hand, EEG has a very good time resolution, and it also has very low cost. In addition, it is more portable and also it's non-invasive. It also has no real safety restrictions, so that EEG is kind of widely used for brain imaging. And actually, that's also my focus of the presentation. So first, I will introduce the electrodes and amplifiers that can be used for EEG recording. As you probably know, the EEG signal is very weak. It's in the range of microvolt. So you need to really put the electrodes very close to scalp and make good contact. For that purpose, you have, for example, these electrodes here, like A or B. This is kind of wet electrodes, which means you need to place some gel between the electrodes and the scalp to make a good contact. And A is kind of traditional passive electrode, which means you release some kind of abrasive gel and need to scratch a little bit. On the other hand, the B is kind of active electrode, so you just need to insert gel, and the preparation time would be much shorter compared to the passive one. And in addition to that, you may also use this kind of dry electrode that is in C. So this kind of electrode is kind of plug and play, so you don't need any gel. And more recently, we also have this kind of hybrid electrode, which means you can use this electrode both dry or wet. For the bottom bar, there are several different types of amplifiers. You can see the first one, A, that is kind of high density amplifier, which records up to 256 channels and is with cable. On the other hand, we also have different types of wireless amplifiers. So you don't need a cable, which gives more freedom to the user. And actually, later on, I will give more details about these wireless amplifiers. So the first one I want to introduce is the Unicorn device. It is a device with 8 channels and with a resolution of 24 bits and a sampling rate of 250 Hertz. So it is featured with like top EEG quality data acquisition. And it is based on the hybrid electrodes, as I mentioned before, so you can use this for dry or wet recordings. And we also have like a customizable and programmable software tools that you can use together with this device to do the data recording. So, oh, sorry. Here, I just show you a picture about the device. You can see here we have 8 hybrid electrodes. And here is their amplifier. It includes also a battery and also a Bluetooth module there for the wireless data transmission. It is very lightweighted, it's wearable, so it's kind of easy to use. And I can also show you a video about the data recording. So you can see here it's 8 channels of EEG data. It is quite stable, even with some movement like clenching the teeth. The data quality is still very good. And here my colleague is going to do a flip, and you will see how the data looks like. Here you see the noise exists for a couple of seconds, and then the signal basically goes back to normal just shortly afterwards. So this is kind of a feature for the Unicorn device with good data quality. And another example I want to present is a kind of multi-purpose device. So with this device, we could not just measure EEG, but also other physiological signals like ECG, EOG, or EMG with the same device. it is also possible to combine these EXG measurements with external sensors, for example, the GSR or respiration. So it also has a internal acceleration sensors inside, which means you could also measure the head movements with the same device. And here is just an example about the like experiment setup. So here you can see with this multipurpose device, we could measure here 7 EEG channels plus a reference and a grounding. We have one channel for the ECG, which measures the heart activity, and we have one channel for respiration and one channel for the GSR that measures the skin conductance. I will also present this software that is used to record these multiple biosignals. And we also have this is developed based on the MATLAB Simulink. So you can use this one to not just record the data, but also do some basic analysis like pre-processing, feature extraction, and even classification based on different types of biosignals. Also, I'm going to show you a video about this experiment setup. So here you can see the preparation of different sensors. The first one is the ECG sensor that records the electroactivity from the heart. So we just need to attach the ECG electrodes to the body, or this would record the activity from the heart. And the second one is kind of a test bed that can be used to record the respiration. So it basically records the waveforms of the respiration with this test bed. And in addition to that, we could also add these GSR sensors to record the skin conductance. So we put the sensors to the fingers, and this will also go to the same amplifier that records the ECG, respiration, and so on. So you can see here, it's attachment to the fingers for the GSR sensors. And of course, with all these sensors, and eventually we also need the EEG cap for EEG recordings. Here is a different setup, but basically shows the principle that the same amplifier can be used to record multiple biosignals, not just the EEG, but also other like ECG, respiration, and GSR. Because of the time, I'm not going to much details about it. So I'm going to move to the next example. That's kind of multimodal imaging. Before we talking about the EEG and stuff, it's mainly the recording of the electrical activities. But in addition to that, we could also use the same device to record the FNIRS. That is kind of optical imaging, which measures the hemodynamics of the brain. So as you can see here, we have like two models. The bottom part of this amplifier for the EEG recordings, and we also have the upper part that is the FNIRS device that is from Artenis companies in Netherlands. So with this device, we could measure EEG and FNIRS simultaneously. And you could even place the FNIRS sensors at different locations. If you want to record more the frontal area, then you move a little bit frontal. If you are more interested in the motor cortex, you could place it on more on the motor cortex area. So with this same device, we could do kind of multimodal imaging, which records the electrical activity from the brain with EEG and also the optical imaging using FNIRS. So here is again the software together with this multimodal imaging. So we developed this based on MATLAB Simulink, which allow us to record up to 64 channels of EEG and together with 8 channels of NIRS. Also, we have this like integrating our GHISIS, that's a software package developed by GTEC, which can be used to record the EEG and FNIRS data. We also have it integrated into the GBA analysis. That's kind of offline analysis software, which can be used to process the data afterwards. So for the GuestXR application especially, we could also combine the EEG and even the FNIRS recording together with via headset, as you can see here. So you see there, like the via headset is kind of attached on top of the EEG device, and when the user is like exploring some task in the VR environment, we could measure the EEG or even FNIRS activities simultaneously. This can be used to investigate, you know, the users' activities during this VR environment. So for the last part, I want to also to present the EEG hyperscaling. So before we was talking about the brain imaging on a single subject here, we are talking about record 2 or more subjects simultaneously when they're performing certain task. As you can see in this photo, and the musicians, they are playing while the EEG data recorded at the same time from multiple subjects, multiple users, let's say. And this data can be used to investigate the synchronization between these musicians. And another example here is also using EEG hyperscaling, but this is application in the brain computer interface or BCI study. So here we have 8 subjects collected to the same amplifier, and each of them with each cap of 8 electrodes. And they are performing a typical P300 spelling experiment. So the data are collected with the same amplifier and analysis with our Intendix software, and these results are presented in real time. So this is another example about a kind of collaborative task. Actually, currently we are also working with University of Warsaw to develop kind of hyperscaling to record from 2 or more subjects when they are performing kind of collaborative or competitive task together with the VR headset. So they are kind of performing some task with the VR headset on top of it, and we are like measuring the EEG simultaneously. So at the end, it's just a very brief summary about my presentation. So I give a very brief introduction about the brain imaging and mainly about the EEG part. That's actually the main product lines of a company. And I introduced the Unicorn device that is a wearable EEG headset with very high quality. And I also introduced the Gelatinous device that can be used to measure different physiologic signals with one wireless device. It is also possible to do multimode imaging with FNIRS, and it also gives us the option to combine with VR headsets. And lastly, I mentioned the EEG hyperscaling. So we can use the device to record like 2 or more subjects simultaneously. This can be used for the GuestXR study and also probably the OpenCall. So that's all from my side. Thank you.
Outline. Since we are just a bit late, we move to the next presentation. That is the last one before the question and answer session. So we have the presentation of Anatole Lecouillet about haptics technologies. He is, let me just introduce you one minute. So Anatole is the head of hybrid team at the INRIA Center of Rennes University. And he has been leading a research activity on virtual reality for the past 25 years. And his main research interests are in 3D user interfaces, brain-computer interfaces, and haptics. So thanks a lot, and I give you the floor.
Thank you, Simona, for the introduction. I hope you are hearing me well. I'm going to talk about the haptic technologies that are designed in the GuestXR projects and that we put at disposal for this open call. So we are open to collaborations in this open call, and we can propose a few haptic technologies that can be used in the propositions in the project that will be submitted in the open call, and we can share these technologies and provide some support to some extent to these technologies. This is coming from our team, as Simona said, a hybrid team from INRIA, the French National Research Institute in Computer Science, located in the west part of France, in this Brittany region, 1 hour and 20 minutes from Paris. And our group of 35 people is working on virtual reality technologies, but also on the perception of virtual environments and the applications of these technologies to different fields. We notably have this great facility at INRIA in Rennes called Immersia. It's a very large, immersive, and very impressive setup. It's a large cave environment, 10 meters wide, in which you are immersed here using stereoscopic glasses and not an HMD. Of course, we have many HMDs too, but this unique setup is very interesting for different kinds of applications. Here it's a training scenario in the medical field. And recently we equipped Immersia with haptic devices. These very powerful Haption force feedback device enabling to feel here the collisions, the contacts, or the weights of the manipulated objects in this very large setup of Immersia. So we have haptics in Immersia, and actually we have 2 force feedback devices in Immersia, so we can even envision social haptics, interactive situations combining multiple users and sharing haptic information among these 2 users in this impressive setup. Okay, we are dealing with haptics. Haptic is quite popular at the moment in the XR community. There is some kind of haptic hype with many Kickstarters and companies designing haptic interfaces, haptic modules in order to equip the next generations of XR setups and XR HMDs and accompany XR HMDs. In our group, we have been longly studying this field of haptic technologies. It's a long story at INRIA Rennes. We have been working with many different kinds of haptic actuators and haptic systems. We were interested in ground-based haptics, wearable haptics, encounter-type haptics, non-contact or mid-air haptics, surface haptics, etc., etc. I'm going to show you some examples here to show you the great variety of haptic technologies existing in the field. This is just a small subset of exemplar and illustrative technologies. Here at the bottom right, you can see an encounter-type haptics. It's haptics on demand, an object which is coming in contact with your palm whenever you are grasping a virtual object, and it's released from your palm when you are releasing this object. So you can grasp and release virtual objects and feel the grasping using this tangible device here with this encounter-type haptics. Here it's an example of ground-based haptics, this little force feedback arm, which is enabling to feel some kind of haptic sensations when touching this surface, this tablet, and you can feel the image on the surface, the properties of the image like texture, relief, friction or sliding effects by playing those force feedback effects at the level of this device here. Here it's a wearable device. We have different kinds of wearable devices available in our lab. This is a wearable device which is enabling to exert a certain pressure at the phalanx of the finger, increasing the stiffness sensation of this tangible device here. And here it's a mid-air haptic. setup. So it's based on ultrasonic system, which are providing remotely some haptic sensations at the level of the hand here. And here the original idea here was to extend the workspace of this very small workspace-based interface by putting this device on a robotic arm, which is moving the device and extending largely and considerably the workspace of this, enabling to touch 3D holograms here and feel the holograms in 3D in a larger workspace. Okay, so when we go now into the topic of social interactions and the core scenarios and use cases of GuestXR, of course, haptic could play a central role in many of these scenarios because haptic feedback plays an important role at various moments of social interactions. We all can think of classical examples of haptic interactions occurring in our daily life. I'm thinking of hugs, high five, fist bump, handshaking, shoulder tapping, stroking, caressing, etc. It's interesting in haptics that it's a bilateral situation. You are touching, you can be touched, you feel also sensations when you are touching something or somebody. It's also a pretty intimate notion. So we have to be careful also with what we are proposing because there are cultural aspects, there are individual variability and sensitivity varies with respect to haptic stimulations and haptic cues. So overall, it's actually a very active field of research in the haptics community, and we refer to this kind of results under different terminologies like social touch, affective haptics, and so on. You can find many papers on this topic. In the GuestXR, we have a progressive approach for incorporating haptic technologies in different scenarios of social interactions. It's illustrated on this figure. We can imagine direct contact or indirect contact between participants of our scenarios or experiments or applications. You can, of course, in direct contact experience the other direct contact, and you can touch each other's body. It's this high five here, which is illustrated on the figure. This is pretty intrusive. There is also indirect contact. You can experience the other's actions or presence remotely. For instance, here when one user is sitting on the sofa or on the bed, your body is actually feeling the movements behind your body coming from the sofa, and you can feel the presence of somebody else by the haptic cues coming from indirectly from the bed or from the sofa. But even more surprisingly, you can also imagine other applications or other contexts in which haptic cues can support social interaction. For instance, in the context of communication, with non-verbal communication or verbal communication enhanced or augmented with haptics, either for communicating the other's mood, for instance here the good or bad mood of somebody by means of affective haptics displaying the affective or cognitive states of somebody else, or the direct verbal communication enhancing the speech of someone else with haptics. I'm going to show you in a minute how in GuestXR we have proposed such kind of scenarios. So it opens here the range of scenarios that could be addressed in this open call and how haptics could support this different context of social interaction. So let me show you some example here of setups that we have designed and technologies that we have designed in GuestXR for these two last items dealing with communication, non-verbal or verbal communication. I'm talking first about this very simple but very convincing and effective novel haptic interface, which we call the compression belt or the breathing belt. It's a very basic haptic system with only one actuator and this little belt here, which is exerting pressure on your abdomen. And actually, we have different versions of this prototype. You can see on the right here the latest version, which is more miniatured and more compact. And we have several prototypes of this belt that we can spread in the consortium and in the different projects of the OpenCall. Here is an illustration of this virtual bait in use in this scenario where you are embodying an avatar and feeling the virtual exercise, the virtual sense of effort or effort of walking in this scenario by means of this multisensory display using this haptic compression belt to display the virtual breathing of your avatar, which pace is increasing, the frequency of the breathing is increasing with the effort. So the breath is progressively making a faster pressure on your abdomen to simulate the exercise of your avatar. And more recently, we have incorporated this belt in a scenario in which we wanted to foster empathy between people during virtual meetings. And the idea was to use this belt as to convey the affective state of another user. Here, the stress level of another user. So imagine you are in a meeting and you are seeing somebody else presenting. It's the scenario that we used. And this other presenter is facing a stressful situation and the stress level is increasing. And so the belt here and also vibrotactile feedback at the level of the wrist is displaying the stress of this other person. So you are perceiving, you are receiving the stress level by means of physiological feedback of this other user. So that's what we tested here in this scenario. The belt and the vibration were here to simulate some kind of biofeedback of the speaker in front of you, which stress was moving during the scenario. Here you see peaks of stress, 1, 2, 3 peaks of stress here on the display, which were corresponding to increase in the frequency of the heart rate and breathing by means of the vibration and the compression belt. And the first results of this experiment, which were very preliminary, showed that for some participants, it really increased the empathy toward the other person present in this scenario. Of course, there are other ways to use this belt. We can think of simulating the pressure, the anxiety increasing from certain situations, or simulating different kinds of contact with other people, like virtual hugs. Okay, this is another completely different result that was also obtained in GuestXR called persuasive haptics. Here we have shown that using haptics, very simple haptic rendering can increase self-confidence, persuasion, or trust during virtual meeting. And we use this simple setup in which you have a vibrotactile feedback in the end, which enable to translate the speech coming from yourself or from another person into vibrations. And when you are speaking, your speech is automatically transformed into a vibration that you perceive in the end. And what we found in this paper, which was recently published at IEEE 2023, I'm not going to enter into the details, is that receiving this vibration synchronized with speech, either your speech or the speech from another, is actually artificially increasing significantly the confidence that you have in what you are saying or what the other person are saying in presence of this vibration when compared to the absence of this vibration. So it's significantly, this vibration is increasing co-presence, leadership, and self-confidence or confidence in the other's talks. So that's super interesting. And in summary, what we can offer in this OpenCall is, of course, a support and an access to these technologies. We were thinking of proposing to rent, to give access and to propose a prototype of a compression belt if it's meaningful for a project. To also give an access to persuasive vibration system, to this algorithm translating speech into touch and increasing self-confidence in different kind of scenarios, or also give an access, let's say, for instance, 1 week in Immersia, in our facility in Rennes, to design haptic feedback and haptic cues using Immersia and this very complex setups involving 2 force feedback devices for multiple users in Immersia. So that's what we could offer in this OpenCall, and we are ready to and we are excited to hear and to receive these applications. This is concluding my talk, and I'm just finishing by showing the team at INRIA, which would be in contact with the applicants of this open call for supporting with haptic systems from INRIA. This concludes my talk. Thank you, and let's continue, Simona.
Thanks a lot, Anatole. During the last weeks, we had the opportunity to test a few of your haptics, and it was really nice. So yes, so we move to the to the question and answer session now. So I would like to ask all the speakers to open the videos, the cameras, for taking the question. We have already a few. So I would like also to thank all the people that introduced themselves. I think it's nice, and for the speakers also good to know who is attending our webinar. So we have two questions for Bernhard. So the first one is from Antonio Montes de Miguel. And he's asking, among the GuestXR resources, is there the possibility to use open hardware project northstar.org headset?
I don't really know. Have to investigate. Currently, we are building for, well, we're using Unity to build, and that the quests are based on Android. So our main build target is Android. We've tested a little bit with Pico, but not with this device. So yeah, we would have to look into it, but well, I don't know.
Okay, so then the second one is from David. We don't have the surname. And how are you capturing body movement using the Quest?
So yeah, we're using the standard Quest tracker. So there's hand tracking and head tracking, and we are extrapolating the rest of the body using inverse kinematics and locomotion systems. So the upper body through inverse kinematics from the hand and head, and lower body just extrapolating the head movements as well. Okay, so no additional trackers currently.
Then we have a question for Ren Chu from Kelsey Onderchik. I hope I'm pronouncing it properly. So what would be the max scale possible of the hyperscanning setups?
On the scale, I think he was talking about the number of participants. So this may depend on the hardware. I mean, as the example showed, if each of the subjects has 8 channels, and we showed an example of 8 subjects, that means 64 channels. I mean, for our amplifier, the high density amplifier, which can record up to 256 channels, so you could have an even larger number of participants. But if you consider a wireless device, of course, this might be more limited depending on the capacity of the wireless transmission. So if you have lots of wireless devices in the same room, the wireless channel might be occupied and there's might reach the limit. So yeah, as I said, it really depends on setup and the number of channels and the hardware you're going to use.
So we have then last question in the chat that I think it's open to everyone. Again from Antonio Montes de Miguel. Is there a simple device initiative to draw like an XR charcoal? For us, it is somewhat strange to draw with the trigger of the controllers, and alternatives like Logitech's VR ink are too much expensive. So I'm not sure who could be the target of this question. So for sure not myself. So please, any volunteer?
There's nothing in GuestXR right now that does that, as far as I know. But it's an interesting project idea. would encourage you to pursue it.
I think that there was some demos of Quest Pro controllers that allowed you to draw, but we haven't exploited that capability. I think that's the closest I could think of from that.
So then we have another question from David. Would it be possible to integrate some kind of full body tracking into the GuestXR system? So I suppose some kind of cameras, external cameras, or...
It's all possible, but probably not for this OpenCall. I mean, I don't think we would. Yeah, I mean, if there is some simple way of connecting devices, then yes, but I don't think we would do it for just for one use case.
I think we do not have any other written in the chat. I don't know if there is someone from the audience that want to...
Can I just go back to the previous question? Because there is a possibility where in some of our work within UB, if you have foot tracking, it will automatically incorporate it. Or for example, it also works with a Vive device, which also can do foot tracking and so on. So there is a possibility to use whole body tracking.
Yes, he's also adding that maybe streaming motion data and using Bluetooth. I don't know, just they are like brainstorming in the chat, so sharing with you their thoughts. And again, I was saying that if there is someone that wants to raise the hand, there is like a few minutes more to take a question. No. So now we move to the next part of the webinar, in which we are going to explain a bit more about the guidelines and the process for the application. So thanks a lot for the speaker of this first part and for the technical part. So let's move on. I would like to welcome Luis Vignier from EURECAT to give the next presentation, as I said, about the OpenCall. Luis Vignier is a consultant at the Innovation and Ecosystem Policies Department of EURECAT, and he is the OpenCall manager for GuestXR project. Thanks a lot, Luis.
Thank you very much, Simona, for the introduction. Hello, everyone. Hello, everyone. Thank you very much for your presence here today. As Simona said, I am the OpenCall manager for GuestXR, and what I'm going to explain a bit right now is what are the guidelines for our OpenCall, the main guidelines, and of course the application process that you can find once you apply to our OpenCall. Again, of course, if you have any questions regarding both technological and administrative issues, please write them down in the chat, and then we will try our best to solve them. Regarding our OpenCall, first of all, we're going to start with what do we offer. Of course, my colleagues have already explained what do we offer specifically, but giving a general overview of the OpenCall, we're going to launch this call for interested individuals or organizations that want to participate in a use case that integrates extended reality technology in novel applications. We have already opened the OpenCall. It started in the 12th of June. And it's going to close on the 30th of September. So you have pretty much 3.5 months to prepare your best proposals in that matter. We're going to select one use case from all the applications that are going to be presented. What we offer is, as my colleagues explained, is the total support of our consortium to develop your proposed project. You will have access to the technologies that my colleagues have already previously explained, and also you will receive support of the consortium in the form of, for instance, specific training, specific advice for you, specific ways and advice of using our technology, and also ways of implementing your project as well. Also, the winner will have access to the social virtual reality applications. Also, as they have explained, the developed tools for AR and VR technologies regarding remote collaboration and embodiment. So pretty much you will have access to our technology and support from our consortium to develop your proposed project. What we are looking for is mainly projects or that you are going to use our system, our GuestXR system, for social issues. Okay, we understand social issues as a broad topic, but we can include. These are some examples. These are, as I said, examples. They are not limited to. You have your own conception of what social matters and social issues are, and pretty much they fit with ours probably. But some examples here are, for instance, facilitating education, reducing conflicts between social groups, facilitating psychotherapy, improving cultural experiences. I've already read some questions regarding someone that was already involved in cultural experiences, so that is really interesting for us. Also reducing inequalities of any kind, such as gender inequalities, race inequalities, monetary inequalities even. But as I said, these are some examples, just some examples, and we are open to pretty much everything that is related to improving social matters in any way. Regarding of who can apply, geographically, we accept applications from any person or entity registered in a country participating in Horizon Europe. We are including also third countries and countries in transitional arrangements. This list of third countries and countries in transitional arrangements can be found in our website, so you don't have to worry about that. Of course, if you have any specific doubt, any specific questions about if your country is eligible, please let us know. But as I said, our guidelines are pretty good at self-explaining, so we are attaching a document including all the countries that are eligible for our call. And regarding the goal of the person or entity that is going to apply, it has to have a social impact as a goal, whether as intrinsic in the organization values. So for instance, we accept application from companies that have already a strong corporate social responsibility, or the social impact is inferred from the proposed application. So we are accepting applications, for instance, from schools and entities in the educational sector, artists, NGOs, researchers, and universities, of course, social and third sector organizations, social businesses, and also businesses that have, as I said, a social solid responsibility strategy. And also we want to point out a really important part, which is the consortium between companies are not allowed. So please you just have to take this into account. Okay. Regarding our calendar, as I mentioned, we are opening the calendar we opened the calendar, the open call, in the 12th of June. We're going to close it on the 30th of September. So you still have lots of time to prepare the application, but please don't wait too long, as of course it is better to have it as soon as possible. And during October and November, the evaluation committee will get together and evaluate the applications during a month and a half. And the 20th of November of 2023, we're going to announce the winner. And we will open a short process in which applicants will be able to ask for feedback. And of course, if they don't agree with the feedback that they are provided with, they can start. They can submit a request for redress, in which, in this case, if the request is accepted, we are going to reevaluate their proposals, taking into account their objections. We're going to start once we select the winner. The activities are going to start on the 25th of January 2024, and then we're going to finish approximately 1 year later on the 2nd of January of 2025. Okay, so once you start the application process, here I'm going to give you a brief overview of what are we asking for. It's a really easy to see formula, so you can see. I cannot. Do you see my mouse? Well, actually, it's in the OpenCall website. You can have it here. As you see, there's the application guidelines, which you can download. It's a PDF. It's a really self-explanatory PDF that contains all the information for you. Because if you can find something in the guidelines, please contact us in the mail that is provided, and we will answer it the best way we can. And then you can in the informational page, you can also apply for the open call. After you read all the important documents, you will start the process. You will find a formula approximately like this, in which you're going to be asked a few information, which I'm going to develop right now. Regarding the application at the very beginning, we're going to ask you for personal information, professional data, and a short presentation about you. So we are pretty much interested, for instance, in things such as the name of the organization or your name if you're an individual, what is your postal address, country, this kind of contact information that we need, of course, to contact you in case there's some problem, or in case if you're lucky to announce you that you're the winner. And after this, we're going to ask you to provide a short presentation about you. Pretty much, we want to know what are your main goals, what is the sector you work in, what are your professional objectives, a bit of the trajectory, maybe even. You can include your CV here, for instance. Also, you will find that in each section, there's a possibility to attach a document, so please feel free to attach any document that you might find useful. So for instance, as I said here, a presentation of your organization, a bit of curriculum, wherever you might think can come handy for us, please don't hesitate in uploading it. Also, then we will ask you to describe a bit the problem. What are the objectives that so what are the objectives of your proposal is going to solve? What kind of problem do we have in front of us, and what is the societal issue that we're going to tackle? So pretty much with your participation in the open call, what kind of problem do you want to solve? Okay. After that, we're going to ask you, After that, we're going to ask you for the proposed solution. So which pretty much what actions do you propose to address the problem? And how, actually, this is really important, how are you going to implement them? We don't want to just be limited to a really general issue on what are the actions, but also what is the process that you're going to use? What is the methodology? How are you going to make these actions that you propose actually happen? So for us, it's both equally important, what is the project itself, the actions of the project, and also how you implement this project, okay? Also, please make specific reference to the roles of social virtual space and our virtual agent, the guest. So please, we ask you what role is going to have our technology in your solution. Don't think about the role of the guest after suggesting the project. Please incorporate this role while you write in this specific part, okay? Also, please make reference to any artistic component that you have in your presentation, in your project. This is really important for us. We have a really, as you will see in the guidelines, it's really important for us that there's a certain aesthetics or artistic component in your solution. So please make sure you add it, okay? Because everything that I'm explaining right now, you have it in the screen. It's really summarized, but you have all the guidelines. The document that I told you before is really self-explanatory, and you will find all the information you need there. After that, we're going to ask you for the impact, pretty much what are the possible outcomes that could result from your involvement on the open call. So we want to know, as a result, after applying the process, after implementing your first solution, what social impacts are we going to have? Of course, the more impacts we have, the better, and we don't have to be limited to social impacts. If there are more impacts, such as, for instance, environmental impacts, we will appreciate it and take it into account. It will, of course, be more points for your application. Yeah, also including an examination of how your project contributes to the advancement of extended reality technology and GuestXR and its potential to address societal concerns, okay? After that, we are asking you what are the essential resources that you're offering from your organization, or if you're an individual from yourself, for the proposed action. So of course, as I said, for us, it's really important, the implementing process. So please, we are asking you to include anything that you bring from your side, such as labor, material, expertise, etc. And also, I'm asking you again to include any potential documents that you might find handy for us. So for instance, the curriculum would be a really important part here. Also, any presentation that you may develop for your own resources, we are going to take this into account positively. Yeah, After that, we are opening a bit of space in case you want to provide even more documents. Please feel free to add them. We are going to take into account everything that you upload. So as I said, many organizations have, or companies or universities have presentations of their work or of what they have developed so far, etc. So please, it's up to you to upload these documents here. So please do it if you find it useful for us and for the evaluation committee to take your proposal, to better consider your proposal for our project. Finally, we're going to ask you to authorize personal data proceeding and a declaration of honor in which pretty much you state that of course, the information is accurate, truthful, and comprehensive for us, and also that there's no conflict of interest with the evaluation committee. Please read this administrative part carefully, but there's nothing that should worry you. There's nothing really different from what you probably are used to sign. So just please take a check. And in case there's a point that concerns you, write us and we will answer your questions. Finally, regarding the eligibility criteria, there's a maximum number of points of 30. The evaluation committee will take 2 experts from the GuestXR consortium to assess your application. And from these 30 points that I told you, it's going to come from an average score of the members of the evaluation committee. We agreed that the criterion must have a threshold of at least 2 out of 5 in order to qualify. There are 6 main points that we are going to evaluate, which is the plausibility. First of all, is the plausibility and feasibility of the project. So mainly, how is the project going to be implemented? As I told you, we'll really take this into account within the given time frame and budget. Of course, you can present a really huge project that we would all love, but if there's a project that will take 4 years to implement, it doesn't make sense for us. It has to be constricted within the boundaries of our project. Also, the degree of 2 part of innovations here. What is the degree of standard innovation in technology terms of your approach, and what is the degree of social innovation achieved by your proposal? Also, the efficiency of resources that they're going to use. What is the best use that you're going to make of the available resources, including time, budget, human resources that you may dispose within your organization? Also, part of ethical engagement, what are going to be the ethical implications of the use case, whether they have been fully considered, and how the use case reflects or responds to the ethics throughout GuestXR. Finally, as I told you, as I informed, there's going to be an aesthetics artistic component. So please take into account there's a certain degree of creativity that we're going to evaluate. So please take it into account while using colors, shapes, textures, other design features that you may find interesting in your project. As I said, please take into account these 6 criteria while you are writing your proposal. We are going to evaluate. They are all weighted the same way. So please take the 6 into account, and while you're writing your proposal, write it with these 6 criteria in mind. So, as I said, this is all from my side. We are already welcoming, as I explained, your applications. We encourage you to apply. Your deadline is 13th of September, so please take your time to prepare the applications. And in case you have any issues, please contact us in the email that you have in your screen right now. Thank you very much for listening to us.
Okay, so thanks a lot, Luis, for the clear presentation. We have indeed a few questions for you.
Yes.
Okay, the first one is from Casey Onderjik. Is there any chance that multiple winners will be chosen, for example, when these are smaller projects, each using different resources of the consortium, or can there really only be one winner?
Yeah, thank you for your questions. There can only be one winner. That's a really closed issue, and we are bounded because of this project in that sense. So we are pretty concise in that. There's only going to be one winner here.
Okay, thanks. Then we have another one from Nina. Is there a way outside of the winners to access resources offered by the consortium? For example, other research partnerships?
Yeah, that's a really interesting questions. As they are outside the open call, I suggest that you might contact Simona, our coordinator in that matter, and she will she will manage your question accordingly.
Yes, I will. Then from Lisa Izzuzi, are there any ethics guidelines to take into account?
Yes, you can find them mainly in the PDF that I told you about, the guidelines of the open call. But also, if you have any specific concerns about the ethical guidelines, please contact us in the GuestXR open call mail, and we will develop it more.
Okay, and then we have two questions from David. Would it be possible to get a demo of GuestXR to enable us to get a sense of capabilities of the system?
Well, that would be a matter. I suggest that you email it to us and we would take it into account because we haven't forecasted this. So please, if you're interested in taking a demo or similars, please email it to us and we will try our best to satisfy your request.
Yes, also I suggest you to connect to all our social network and YouTube channel and so on, so you can get closer to all the different technology that we have been recording in different videos. And this can be at least a first approach to them. Then the second question from David is, are applicants from the UK eligible?
Yes, UK is in a transitional arrangement with Horizon Europe, so in that matter, yes, UK is eligible.
Okay, then another question from Lisa. Are there any possible IP issue in case of commercialization of the project?
Yes, there are, but this is a thing that we will agree with the winner once we select the winner in the action plan.
Okay, then I think that you answered all the questions. I don't know if there is any other person from the attendees that would like to open the
I
microphone.
think Ali has asked 3 questions, which I cannot answer right now. Yeah, can I apply for the OpenCall as PhD student? Yes, you can, Ali. No. If I understand correctly, the project should be framed in 1 year duration and more correct. Yes, correct. Just 1 year duration until 2025. Apart from technical support, what is the available budget? There's no available budget. There won't be funds offered to the winner, just access to our technology. So there's no minimum or maximum for each project. So in case you want to provide your own resources, we won't put any obstacle to that.
So again, I don't know if there is someone that wants just to open the microphone for the last question. No, so thanks a lot, Luis, for your speech. And so I hope it was useful, a useful webinar for all of you to understand exactly what we are offering from GuestXR and which is the procedure you have to follow in order to make the application. So you can contact us in the case you have any specific need. Here you have the email that is just reported in the chat. So we hope all of you to get all of your applications and that our new use cases will be really innovative and also with including social aspects. Thanks a lot for being here and see you soon. So bye.